Welcome to this lesson about mathematical functions. Functions are a fundamental concept in mathematics and are widely used in various fields including science, engineering, economics, and computer science. Today, we'll learn about what functions are, their key components, and how to identify them. Let's start with a basic definition. A function is a special relationship between two sets where each input is paired with exactly one output. You can think of a function as a machine that takes in values, processes them according to a specific rule, and produces a result. Let's look at the key components of a function. A function has three main parts. First, the domain, which is the set of all possible input values. Second, the codomain, which is the set of all possible output values. And third, the range, which consists of the actual outputs that occur when we apply the function to every element in the domain. Let's talk about function notation. We typically represent a function using the letter f, and we write f of x equals y to indicate that the function f maps the input x to the output y. We also use the notation f colon a arrow b to represent that f is a function from set A to set B. Now, let's look at some examples to better understand functions. Our first example is the squaring function. We define f of x equals x squared, where the domain is all real numbers. Let's create a table of values to see how this function behaves. Let's visualize this squaring function on a graph. Here's the graph of f of x equals x squared. Notice that it forms a parabola that opens upward, with its vertex at the origin. The range of this function is all real numbers greater than or equal to 0, since squares are always non-negative. Let's look at another example. Example 2 is an age category function. This function takes a person's age as input and assigns them to a category: child, teen, or adult. According to our rule, anyone from 0 to 12 years old is classified as a child, anyone from 13 to 17 years old is a teen, and anyone 18 or older is an adult. Now, let's learn how to determine if a relation is actually a function. There's a simple rule. A relation is a function if and only if each input is paired with exactly one output. Let's look at a non-example. This relation is not a function because the input 2 is paired with two different outputs, 3 and 5. There's a graphical way to check if a relation is a function called the vertical line test. If any vertical line intersects the graph more than once, then the relation is not a function. Let's see this with our squaring function. Any vertical line will intersect the parabola at most once, confirming that it is indeed a function. Let's talk about why functions are important. Functions are fundamental in mathematics because they model relationships between quantities. They're used in countless applications. In physics to model how objects move, in economics to model how prices affect demand, and in computer science to process inputs and produce outputs. Let's practice what we've learned with some examples. First, let's define a linear function h of x equals 2x plus 1. Let's find some values. H of 0 equals 1, h of 2 equals 5, and h of negative 1 equals negative 1. Now, let's check if this relation is a function. 1, 4, 2, 8, 3, 4. This is a function because each input has exactly one output. Let's summarize what we've learned about functions. A function is a special relationship where each input has exactly one output. The key components are the domain, codomain, and range. We can check if a relation is a function using the vertical line test. Functions are important because they model real-world relationships and processes. Keep practicing with different examples to strengthen your understanding of functions.